Hi, Marie. I think I can see why you're having trouble with this problem, but it really shouldn't be giving you that much trouble. But let's check this out for a second. So you have 8x to the fourth, y to the fourth, plus 4x to the fourth, y to the fourth, right? So when you did the factor tree, you had 2 to the third, x to the fourth, y to the fourth, plus 2 squared, x to the fourth, y to the fourth. And when you do a greatest common factor, you take the lowest power of each of the ones that are the same, right? So the lowest power here is 2 squared. Lowest power of x is x to the fourth. Lowest power of y is y to the fourth. But then what are you left with inside the parentheses? When you take out 2 squared, you're left with a 2 from this one. And when you take out 2 squared, x to the fourth, y to the fourth, you're left with 1, right? Because you took out the whole thing. Factored out, like divided it out, right? So that's kind of weird because you're left with 2 plus 1. And that's really strange. Like, why isn't there a variable here? Why isn't there there? So basically you have 2 squared. Whoops, let me write that what that is. That is 4 x to the fourth, y to the fourth, times 2 plus 1. So let's just check that I did that right. So whenever you want to check if you factored something right, you just distribute again, yes? So this would be 8 x to the fourth, y to the fourth, plus 4 times 1 is 4 x to the fourth, y to the fourth. So did I get the same thing I started with? Yes. Okay, you say, but that's really weird. Why do I have this 2 plus 1 in here? Because I can actually simplify that, right? So what happens if you do that? Let's make this 3 times 4x to the fourth, y to the fourth. What is that? That would be 12x to the fourth, y to the fourth, right? Because you multiply the coefficients. Well, guess what? If you had just added these together, because these are like terms, right? X to the fourth, y to the fourth, that's actually the same as if you had like x squared or y to the third or whatever. You can just add the two terms together, right? X to the fourth, and look at that, they're the same thing. So in this question, they're asking you to actually like find the greatest common factor and factor it out. But in reality, to simplify that problem, you didn't have to do any factoring because these two terms were like terms and you could have added them together. Okay, so I hope that that helps you understand this. But the idea of factoring out the greatest common factor is just finding two terms. Finding the greatest common factor and seeing what it is. So let's just do one more example like that because I know that you can do this. We've done it before a lot of times. Okay, so let's pretend this is the problem that you had and it's not as nice as the other one. So we're going to factor this into 2 squared times 3, x squared, and y cubed. Then we're going to factor this one into 3 squared times 2, right, 9 times 2, and x to the fourth, and y. Okay, so the rule is that to find the greatest, you take the least exponent of every factor. So is 2 a factor? Yes, but there's only 1 over here, so I'm going to take 2. Is 3 a factor? Yes, but there's only 1 over here, so I'm going to take 3. X squared, and then y. So 6x squared y is the GCF of these two terms. Okay. So now there's going to be a term here and a term here. It's probably going to stay negative. So what am I going to put in each of those spots? If I factor out 6x squared y from 12x squared y cubed, take out a 6, what am I left with? A 2. Take out an x squared. Are there any x squareds left? No. Take out a y. I'll be left with a y squared. Right? Because there was a y cubed there. If I factor out a 6 from the 18, I'll have 3. Factor out an x squared from the x to the fourth, I'll have an x squared. And if I take out the y, that's all I have left, right? There's no other y's in that. So that's the complete factorization. 6x squared y is the greatest common factor, and then 2y squared minus 3x squared